Very good morning to you, and thank you very much for joining our Norway Scotland collaboration workshop. My name's Jaya Calder from Highlands Enterprise, and I'm going to be running your webinar workshop this morning. Just a bit of housekeeping. If you're new to GoTo, although we are not able to see you and you're automatically muted, we actively encourage your involvement throughout the whole session. So what you'll see is a question box. Now please put your questions in throughout the whole of the session. We will have a short time at the end to take some of your questions, but if you pop it into the question box when it comes into your mind, we'll capture absolutely everything. The other thing that we need to let you know is we're recording today's session to get the messages far and wide. So I would like to pass over to my colleague Ronnie, who's going to introduce your workshop. Thanks very much. Ronnie.
Thank you, Jaya, and a very, very good morning to everyone, and indeed a very happy Star Wars Day to you. May the 4th be with you. So, welcome to the second in our series of collaborations between Norwegian Energy Partners, Norwegian Offshore Wind Cluster and Deep Wind. And Paul O'Brien will be speaking to us later on this morning from Deep Wind. The idea behind these is really to introduce companies from Norway and Scotland to each other to see if there's any possibility of collaboration or working together or doing things better. So we have an interesting session set up this morning. We've got, as an introductory talk, we've got some speakers from GIEK and Export Credit Norway who are going to give us an overview of what they're doing, and they will be collaborating more fully later on this year, and we'll hear from about that later. We've then got a series of 3 Norwegian companies, Sea Systems, Origio Solutions, Calora Mooring Systems, and indeed 3 companies with bases in Scotland, James Fisher, Bryden Bykert, and I'm hoping I'm pronouncing that better, and SBT Energy Limited. And we will finish off with some Q&As at the end. As Jaya mentioned, please put your questions in, and we will try to get to those to the end, at the end of the session. If we don't, we will try and get answers to you after the session. So if you have questions, please remember to put these in. And as Jaya mentioned, we will be recording this, and this recording will be available to everyone who is registered to attend, so that you can catch up on any of the nuances that you have missed. I checked earlier on this morning about how the demand in Great Britain was working, and just before 8 o'clock this morning, UK time, the demand was being met 41% by wind energy. And that's only going to grow as more and more projects come online. We have about 10 gigawatts of offshore wind in the UK in operation, but we've got about another 10 gigawatts in construction just now, and then a lot more in development. Earlier on this year, we saw under 8 gigawatts being announced by the Crown Estate in their Round 4 process. And we're expecting another 10 gigawatts to be announced by Crown Estate Scotland, either tail end of this year or beginning of next year. So there's a lot happening. There's a lot of market here. And without further ado, I'm going to hand over to Ute Borkad and Eva Logeberg to introduce us to GIEK and Export Credit Norway.
Good morning. I will be the one starting off this presentation. My name is Eva Løvberget, and my role is Head of Energy and Industry at Export Credit Norway. And in cooperation with Ute at GIEK, we have, I have prepared a presentation. It will be a brief introduction to Norwegian Export Credit Agency system and what we can offer to the offshore wind sector. And we will also go through a couple of cases towards the end. And I think we can start off by going to the next slide, please. And thank you very much for the opportunity to come and present the Norwegian Export Credit Agency system. Currently, it consists of 2 players, GIEK and Export Credit Norway. We have, as you can see here, the same owner, the Ministry of Trade, Industry and Fisheries, and we also have very similar objectives to support and promote Norwegian exports. We differ slightly in the way we operate and the products that we offer to our clients. In short, GIEK offers guarantees, whereas Export Credit Norway offers funding. Last year, it was announced that the government has decided to merge the two Norwegian ECAs, and the entity will be operative from July this year under a new name, XFIN, which is short for Export Finance Norway. And the purpose is to make the offered solutions simpler for our customers and also to create a more efficient ECA system in Norway. And after the merger, we will offer the same products as we do today, including guarantees and funding. In addition, we will offer direct lending, which is similar to banks in a way. So we'll have the same offering, but in addition, somewhat more. And hopefully we'll be a leaner and quicker and a better institution to work with. And to wind park developers in the UK buying Norwegian equipment, Export Credit Norway can offer long-term funding up to 18 years from ready commissioned projects, which means that total tenors can be more than 20 years. And we offer both fixed and floating rates and the optionality to choose between them. And this table shows the current fixed rates that we offer for funding of export contracts signed between mid-April and mid-May this year. So as you can see from this table, in the bottom right corner, the current fixed rate for contracts signed today for Norwegian exports to, for instance, UK projects in pounds would be 2.05%. But that's only for the funding part of the lending. The counterparty risk margin will come on top of that. And that would be the part that GIEK could offer for a project. Yeah, and with that, I'll leave the word to Ute, who will go through some cases. Thanks.
Yes. Good morning, everyone. And yeah, thank you, Ivar, and thank you, Nordweb and Norwegian Offshore Wind Cluster and Deep Wind for giving us the opportunity to tell a little bit about financing. My name is Ute, and I'm working as an underwriter in GIEK's Clean Technologies department, focusing mainly on renewable energy projects. So what role does GIEK play and what value can we add to the project? Really, the main advantage for using us is the high standing state guarantees from Norway carry. Our guarantees enable banks, but also life insurers, to provide funding at attractive rates. And we observe that in syndicates, GIEK guaranteed tranches receive amongst the lowest funding rates, and thus reducing the overall financing costs for the borrower, for the developer. Last year, in 2020, we have issued guarantees for more than 7 billion kroner. So we have grown our portfolio in offshore wind considerably the last year. And we are delighted to see that an increasing number of Norwegian companies have won bids within the sector. And given the enormous ambitions now shown by many countries, Ronnie referred to that, not only in the UK, we hope we can help getting many of these projects financed. For you as a supplier from Norway, I recommend to bring this option up for discussion when bidding for a project. The availability of financing from the Norwegian state may help you winning the bid. And even though I understand that most of you in the audience today mainly work with technology, financing is actually critical for succeeding with a potential client. So that's why we are here today. At GIEK, we are closely working with suppliers, with developers, and also banks within offshore wind. And I will now show you some results of this strategic work. That shows our last milestone. The first two phases of the Doggerbank project reached financial close in November last year. And this is a super exciting project from a technology point of view, hopefully contributing to drive costs further down. Here, contracts from IBER and OHT enabled us to participate in the financing which consists of a syndicate of commercial banks, as well as the Swedish and French export credit agencies. The Sea Green project was closed in June last year. In this case, we support cable deliveries from Nexans, and together with Nordea, we are also financing the cable layer vessel Nexans Aurora, which currently is under construction at Ulstein Yard in Norway, and which, according to plan, will be delivered this month. So Sea Green chose turbines from Denmark. So here the Danish export credit agency EKF is part of the financing too. Based on installation services from Fred Olsen Wind Carrier, we guarantee also for parts of the financing package Copenhagen infrastructure partners needed for their Changfan Qidao project in Taiwan. And characteristic for these financings are large syndicates with many banks and often combined with ECA financing. Taiwan is a relative new market, so banks were keen to offload some of the risks to ECAs. But I also wanted to touch upon other products, because GIEC does not only offer long-term financing to buyers of Norwegian goods abroad, we also help Norwegian exporters directly with additional guaranteed products. And amongst these, the counter guarantee is the most widely used. In that case, the picture shows one IBEL was required to issue performance guarantees in favor of their clients, both Tenant in Germany and also the Doggerbank project companies. And within offshore wind, these guarantees often have substantial amounts. So by using GIEC, banks can offload parts of the risk, thus extending the overall credit limit of the exporter. In addition, we also can help finance working capital needed for the production of an export contract, or we can finance an investment in production facilities as long as that leads to increased exports from Norway. All these solutions are based on GIEC sharing risk with the bank. So if you are interested in these solutions and have a financing demand yourself as a supplier, please get in touch with us as well, not only mention it in the bidding process, as I said earlier. So thank you again for listening in, and we will stay here for questions afterwards. So thank you.
Thank you, Ivar and Ute. Not straightforward, I appreciate, and I'm sure that that will have resonated with some people, particularly in these times where finance and reducing cost of finance is key. So if you could stay with us and stay for the Q&A session at the end, that would be really, really good. So if I could move on then, please, to Rune from Origio Solutions. Rune is the Sales and Marketing Director for Origio.
Well, thank you very much for this opportunity and for making time for us. I'll talk about the SCADA systems and a system we've developed ourselves called SCADA Plus. But shortly about Origio Solutions. Next slide will tell you that we're a company with more than 40 years of experience. We've got more than 60 employees, and we're ISO 9001 and 27001 approved. Now, Origio Solutions is a specialist supplier of safety and automation system, and we are really from the operation technology side. Now, what happened is that we deliver the SCADA system. We do have some SCADA system in this, and for the automation side, and we deliver the SCADA system for Highlands, Scotland, outside Aberdeen. So due to that, we've focused a lot on this offshore wind, and we developed the SCADA Plus. Our findings is that, and it is still important, but the focus has much been on the licenses and the builds. Get the license, get the structure, get it cheap, put it out there, get a new license, build it even cheaper, and put it out there. Now, what we've looked at, and as a possibility, and I think that it'd be more relevant, is that what about the next years? What about 25 to 30 years that this is going to run, where you have to optimize your investment? The bottom structure, it's still important. We need to do this, but we also think there's a big potential in increasing the investments for the lifetime of the park. Now, that being said, we're making a system, a holistic system that make you optimize your production through digitalization, artificial intelligence, or machine learning. and also looking at possible effects on the logistics for maintenance. So we looked at what was there today, and what we find is that we know of one control room, there's 22 screens and 5 subsystems. That means 5 alarm systems, different ones. And there's 22 screens with information on it. And we know that one of our sister companies actually tried to remove one of the nacelles. The operator saw a brake was on, and the operator then turned off the brakes while they were removing the nacelle. Nothing happened, but there's huge potential risk factor in having all these systems up and running at one time. 5 different alarm systems, you could miss alarms very easily. So we've kind of stepped back and said, okay, what's happening when you put yourself into a car? Well, you start up and your oil lamp is never green, it's red if something happens. And when you talk about these huge wind farms being 95 on Dogger 1 or and 300 wind turbines, you need to have the information that's relevant on your side. You can't look at everything because you'll miss a lot of important information. And that's why we started on the SCADA Plus development, and we'd rather say in the control room, there's something, notice me when there's something I need to be aware of. So we are connecting various system interfaces into one. So the SCADA Plus is kind of filling the gap to improve your production. And what we're doing is that we are from the control side. So we take all the sub control system, whatever's there. They could be mooring system, it could be a motion control, or it could be possible something from the turbine, the wind, anything like that. Also third-party systems and different sensors. All of this is taken into the SCADA Plus, where we convert the data to structured information. Now this information can then be used by intelligence services and analysis, machine learning, predictive maintenance, and it can also be structured to the management system. Possibly the predictive maintenance tells you that this gear is going to break in the next 6 months. You have it on stock somewhere in Europe, go to the management system and check if it's there. You make it available for that turbine, and whenever there's a service in that area on that turbine, you can ship it. You don't have to do several trips. Possibly also having a checklist for what you have to bring. In theory, a forgotten tool will have you to come back and go out again, which is very expensive. These are the kind of things that SCADA Plus wants to be the orchestrator of. We don't deliver many of these systems, but we deliver the orchestrator, this little figure in the bottom, which is really kind of the idea of SCADA Plus. So what we do is that we bring all this data together. This system platform is usable for green fields, brown fields, and it's a second level HMI system. So we take all the information from the other sub-partners and we make it available for others. And we have one user interface. And this user interface is also taking all the alarms into one. We have a separate alarm system in there where you can add on comments. So you have your experience database in the alarm system and not on someone's Outlook that we've heard of. So if you go one step further, you'll see that when we get all this information, we also have an analysis board and an insight. So you bring all this information into knowledge, and in the end, you bring the knowledge further to wisdom by enabling smart operations by other third parties. Now, this could be something that one of you may supply and one of you may use. We will integrate with any partner you may have, or we may recommend someone. It's as easy as having the wind measurements. Let all that needs this wind measurement have that value and not having to put another one out there. So you have to open up and you make it available for everybody that's integrated into the project. And these are part of the interfaces that we made as templates. These could be obviously changed. We made it available for all interfaces. Both someone wants to do this on a tablet from home, someone wants to sit in an operation room, control room with big screens. Someone needs to have the data for the production on an iPhone or any other mobile device. And this is all made available already. The first slide on the left, you can see that there's several wind farms. So it's more like a management overview. The middle one is an actual wind park in Norway, is a land-based, as an example, where you have some more production. The one with the turbine on it could be the information you get from one turbine. And here are some values with temperatures, production, could be alarm list, work order system could be integrated into this. And then the two bottoms are just different ways of looking at this. There's a single line list on the bottom right, and all these colors could be changed. It's web technology, so you could have different languages easily, time zones, yeah, like I said, colors. And we can also put layers on top of this. We could have a layer having what's your production rate on each and every turbine. We know that the wind is blowing 60-70% of the time from one direction and is optimized for that. That still means that 30-40% of the time it's blowing from a non-optimized direction. Maybe you could see that the front line of your wind turbines are then producing at full speed and none of the rest because of the wake. Now maybe if you turn down the first line, maybe the second line could then start to operate, and then the output of the total wind park would be higher than if you just run the first line in at 100%. Also, the wear and tear might be less. We know hail might damage the blades. Let's turn down the production while the hailstorm's there and then ramp it back up again. You save a lot of maintenance by doing these smart operations and in one system. So that's our idea for the SCADA Plus and Origo Solutions proposal for assisting on the way to give you more out of your investments while the upper park is running. Thank you. And I think I kept my timeline too, Ronnie.
You did. Thank you very much, Ronnie. That was much appreciated. I'm going to move on now to Lars Even Nielsen, who's the Director for Proposals and Marketing at Sea Systems.
Thank you for being invited to present Sea Systems in this forum. I have made a small short presentation to give you an idea of what we are working with, mainly mooring systems for various floaters. We are working in 3 different markets: fish farming, offshore wind, and oil and gas, where we sort of came from. Yeah, we have a history from around 1990 in the oil and gas industry, working with the mooring system, bow loading systems, offloading systems, and so on. But in around 2015, the market went down and we started looking for new markets. And we decided to move on to offshore wind and offshore fish farming. We have already been able to get contracts both within fish farming and offshore wind, and I have, put some examples on we have been, or some of the major projects lately. This is a fish farm that has been installed in Norway, northern Norway. We delivered the turret mooring system, shore power cable, and also offshore installation of the unit. It is nearly 400 meters long and 60 meters wide. Here you see a picture from China where it was built, and we installed our hardware deliveries at the yard in China. This is a photo from Vesterålen in northern Norway, where we were responsible for the installation. We were also responsible for the pre-lay of anchors and chain before it arrived to Norway. And we also had the company rep on board when it was happening. This is another example of what we have been doing lately. This is another fish farm where we develop a new type of mooring connector, where the principle is that you use the anchor handler to tension the anchor lines. There is no hydraulic winches or anything on board the floater, and everything is done in order to lower costs in hardware cost and also operational cost. So this unit will be installed this autumn according to plan. And it will be very exciting to see how it goes. One of the advantages with the fish farming industry is that they are open to new solutions and are willing to try. It's quite different from the oil and gas sector that we came from. So actually these type of mooring connectors, we have got contracts for oil and gas later on with products that was delivered for fish farming. This is just a picture of one of these fairly chain stoppers. Maybe not too much to say about that. And then Hywind Tampen, we have been working with Equinor for a number of years, sort of qualify technology for the mooring system on Hywind Tampen, and we were able to win one contract. Here you see a computer image of the mooring at the bottom of the floater and the mooring system. So we got contracts for the hull brackets. It's 33 hull brackets on 3 on each floater. Exactly 1 year ago we got that contract. And here you see these brackets ready for delivery. Also develop ROV tool to be able to replace the lines in case something happens. Yeah. You can pull out the main shaft with this tool and then lower the bridle and then pull a new one back in again. So the first brackets have been shipped to Norway, and the rest will follow to Norway this spring. Collaborations. We understand that there is a lot of things happening in Scotland, and we are open to collaborate with companies in Scotland. Some examples could be companies with complementary services or product, could be fabrication, or it could be engineering company participating in early phases. For us, it's important to be involved in projects early in order to be able to add value to the project. I think that's all. Thank you.
Thank you very much indeed, Lars. Now going to move forward to introduce someone with a very famous name in Scotland, in Scottish and UK football, Mr. Alan Hansen, who is the CEO of Calora Mooring Systems. Alan, are you there?
I'm here.
Good.
Well, thank you for the kind words and introduction. I do have a memory of working in Thailand, and the bell captain at the hotel, he always said when I arrived that Alan Hansen, the captain of Liverpool, is coming. So that was was always funny. Good morning. Today I'm going to talk about the product that we offer. So we just go ahead. I'll give you a brief history and what this technology enables and sort of the markets and the business model that we are looking at. The picture on the right you see is a demonstrator with the product on an actual rig move back in 2017 in the UK sector of the Verbier airfield. So this is the picture showing the rope with our product on the outside being spooled onto Scandivega. Now the main focus for us was that we were invited by Statoil back in 2010 as one of 44 technologies for the Aasta Hansteen project in order to increase robustness of fiber rope. The Norwegian Petroleum Directorate, they have gone through quite a bit of work looking at various constructions of mooring lines, and the one failure that always occurs with fiber rope is some external impact or mechanical abrasion. And so Statoil launched a project back in 2010. We were invited to develop what the focus in those days was called the CRJ, or a cut-resistant jacket, to be able to withstand overtrawling, pelagic overtrawling. That progressed into being picked as one of 3 for the final tests. And we know that from those tests that we had the good performance compared to the other alternatives. Unfortunately, in that project, the EPIC contract was structured so that all the deliveries for the fiber ropes were going through the rope suppliers, and in our case, the one that we worked with decided to pull out of the bidding, so we couldn't do anything. So Then we started a separate initiative after that in 2013 to commence and further advance the technology and scale it up, which terminated in 2017 with this demonstration on the Verbier field, as I told you earlier. When the demonstration phase was over, we then moved into certifying the technology through the DNV TQ process, which was finished in 2018, and the technology is patented. What this technology does is that it enables fiber rope mooring lines, and it has several features that can be incorporated into the technology. It could be as simple as improving the anti-fouling, particularly interesting, of course, if mooring floaters in relatively shallow water. It can provide very good ROV visibility, also interesting in shallow water in terms of turbidity and so on. And also in deep water, of course, keeping the mooring line in position in terms of various currents in various parts of the water column. We can provide buoyancy. So if you are looking at a rope that has a higher specific gravity than one and it's sinking, we can provide buoyancy capability to keep the rope off the seabed or other benefits you may see with buoyancy. It also has a very good reflection capability in terms of sonar. We have done a lot of testing, and this is a passive system that everybody knows that when you have a lot of construction in and especially in the North Sea, it attracts a lot of fish and then in turn attracts a lot of fishermen. And so there is barrier capability in this technology to make the mooring line very visible on a simple sonar that you find on the bridge on any fishing vessel. Then of course is the abrasion resistance, which could be related to seabed, deck handling, the most severe of course being the overtrawling. We can incorporate colors into these various layers so that if you have a damage, you can easily see how deep you've gone. So here's some more specifics, just looking at the way we can vary the density, 680 to 4,000 kilograms per meter cube. We can actually go even lower than 680, but this has a functionality of water depth. You see the picture there on the left of the sonar prelay test, because one of the limitations that we are actually removing now is in the DNV E303 specification, which prevents you from prelaying rope on the seabed. We have documented in our testing that by adding some layers of this product, we can actually prelay or pre-store mooring lines on the seabed, which is good in terms of either saving storage space on land. It's good in terms of marine installation and also for picking up and retrieving lines, installing lines, and reducing the weather windows and all this type of possible challenges you face when you go to install the mooring lines. And as I mentioned, we can incorporate anti-fouling. And then we have the abrasion resistance, and we talk about what we talk about when we talk about abrasion. We talk about what's called the PV or the pressure velocity limitation. And actually, abrasion is very frequently a pressure velocity in the face of that you are getting in contact with something, and the object moves with a certain velocity that creates wear and abrasion. And we can configure this product to be tailored into various sort of load cases when it comes to wear. And then as you see the picture on the top right, this yellow color is the sort of the standard yellow subsea color that's been in the oil and gas industry for many years. So we are also doing quite a bit of work then, and this was part of the technology certification process together with DNV, that the target was that when the technology was certified, it should be documented that this product and technology does not affect the mooring rope properties, and also vice versa. So it's and this has been documented and done, so it's very easy or relatively simple to establish a liability border between the two. So it's if you think of other business areas within traditional oil and gas, the model we are looking at is similar to what the end users have used for many years, for instance, in rigid pipelines, where they buy steel pipes of any sort of grade from any sort of steel mill or pipe manufacturer, and then submit these pipes to companies that enable functionality in terms of weight. For instance, of these big pipelines sending gas from Norway to UK, whether it's thermal insulation for flow lines and risers, or whether it's corrosion protection for water injection lines and so on. And we see that this can be done the same, and this can also be reversed. I mean, this is not a very big topic. It's just a matter of how you organize it. But we can apply this technology to any rope, whether it's new or used. And I mean, any rope, that means any, whether it's polyester or nylon or Dyneema or whatever construction material that's used, we can apply this technology. And yeah, so that's sort of the business model that we are working on, is to find ways to get into the market at the moment. What we're looking at is, as from the certification process, then is this clear interface that we have established.
Well timed, Alan. Thank you very much.
Yeah.
And just a reminder to everyone, we have some questions in now, but if you have any other questions, please put them in the chat function and we'll get to these at the end of the session. I'm going to pass on now to the Scottish participant, James Fisher, Asset Information Systems, and Bill Bailu, who can speak to us about what James Fisher are doing. Thank you, Bill.
All right, so welcome everybody. Thanks for having us in today. We have a number of systems, and primarily the one that we want to talk about today is our Kraken system. It is currently under development, and we have a digital twin system that we've been using in oil and gas for about 10 years now. But the Kraken system is currently under development, and it's designed to do fault prediction and provide decision support for subsea high voltage cabling. So this could be export cables, it could be inter-array cables, it could be floating or fixed foundation, any kind of application that you might need to be able to do cable monitoring. We also work with a number of other companies as partners who can provide us with additional services to look at terminations and so forth. But as you can see here, it's through the application of data science that we're able to do this. We'll get a little more specific about the problem set we're trying to solve here. The bottom line problem set that we're trying to solve is unexpected cable failures, which lead to unexpected or unscheduled downtime. That can result in all sorts of inefficiencies, penalties, emergency response costs, other kinds of undesirable things that tend to happen in offshore wind in a very dynamic and corrosive environment. So our solution was to apply data science techniques in order to set up a decision support system using any of the incoming data streams that you might have on your wind farm. So this points back to Origo. We might find something else to talk about there. And this could be from the cable fibers or from other types of systems that we'll get into in a minute that you might be using to monitor your cables in order to save money, drive efficiencies, and allow you to optimize what you do with your data. So this allows you to lead digitally. So as I said, we do offer a number of things because James Fisher is made up of a number of subsidiaries, of which we are one. We have subsidiaries that do things like operational risk management. We provide a digital twin. So we're Asset Information Services works in the digital space, trying to help digitalize. We have a high voltage management company in EDS, and this is where we'd like to be able to apply Kraken in the high voltage scene. And then we have a marine management system. We have other types of systems for both monitoring foundations on both flow and so floating offshore wind and fixed turbines as well through SAMs, and we'll get into that a little bit as well. So Kraken was originally developed with our partners at IBM. We were working with IBM to do data science applications on cable data. We were able to get some cable data, and we were able to apply, essentially what we were able to do is look at load and temperature in order to determine free span. So we ran cross correlations against it, and then we developed the front end that you can see on the right on top, which is just a simple interface that tells you about the different conditions at the different segments of your cable. So that could be based on temperature, or it could be based on another system that you may have monitoring your cables. And that could be LIRA, that could be TDR, DAS, any number of these other kinds of data sets that may be coming in either via the fibers or using the sheath and the power core as a setup. We also work with partial discharge and termination testing through another partner. But anyway, on the right, so you can see that's the Kraken module on top, and then on the bottom is our R2S digital twin for offshore wind. So Kraken sits as a module inside of R2S right now. You can use them separately if you like, but we like to combine them and to bring more value to the client. So what it does is it allows you to see how anomalies are developing over the length of your cable. And this could be an inter-array cable, it could be an export cable, or an interconnector. And we look at how the rate of development of the anomalies, run our data science against that, and try to predict when the anomaly may lead to cable failure depending on its rate of development. One thing that I did want to talk about here was floating offshore wind and fixed foundations. We do have a sister company in Fisher called SAMS, part of James Fisher Testing Services and Strainstall, and they develop load cells and other unique and bespoke ways of measuring load and stress on different components of different systems. So they can do it in shipping, they can do it on the turbine towers, they can do it on the anchor chains, they can do it on any of the mooring systems. And what we can then do in AIS is potentially take the data that comes off of those monitoring systems, again, run data science techniques and algorithms against it to find when we think we're experiencing anomalies in the behavior of the system that you're looking at. So are your anchors slowly loosening over time? Are you having weaknesses and anomalies develop in the way that those are behaving, and so forth? And that's what we can work potentially together with SAMS in order to find out. So this is what we're looking at in terms of we would like to be able to partner. We could do this in foundation profiling. We can also do this with Kraken and looking at high voltage systems. And what we're really talking about is the collection of data over a significant time period. So, anything from months to a couple of years, depending on the seasonality and depending on the frequency of data that you have coming in off of your asset, in order to profile, understand, and really map out and fingerprint the behavior and performance of that asset. So once we understand these particular behavior sets, we can look at weather and how those weather factors and other environmental factors cross-correlate with the behavior of the asset in order to hopefully, over time, begin to provide some generalizable profiles to support the understanding of how these assets behave in different environments. So in a warm sea with a different kind of weather profile and a different type of soil in the seabed versus say in the North Sea where it's cold with a different kind of weather profile again. And so we want to really understand how to optimize the way offshore wind is in operation. And that's it. The journey starts here. Our contact information is below. Myself and Laura Fairley, who's one of our BD folks, who works specifically in offshore wind. So if you'd like to know more, please get in contact with us. Thank you.
Thanks, Bill. So without further ado, next up is Payam Purmand from Bryden Beckert, and is going to be talking about their mooring systems and fiber ropes and other parts of the equation, and particularly floating wind. Over to you, Payam.
Thank you very much, Paul, and thank you all for joining this presentation. So my name is Payam Purmand, and I work as a project manager at Bryden Beckert, and I'm mostly working with floating offshore wind projects, and I'm leading an EU-funded project called Mooring Sense. But today I will give an update about our company and the activities that we are doing towards floating offshore wind. So Bryden Beckert is owned by a Belgian company called Beckert. So Beckert is among Europe's biggest manufacturing companies. It's a bit unknown to people, but it's a very big company. It's been founded by Leo Beckert back in the 1880s. He's a bit of a pioneer, and he started off by making wires for the agriculture sector, so mostly fencing and things like that. And gradually the business has grown up, and now we are among the leaders in steel wire manufacturing and rope manufacturing. We are active in most countries along the globe, and we have roughly 30,000 employees, and we are currently listed also in the Euronext Bourse in Brussels. When it comes to the business segments of Bekaert, it's quite wide. The biggest portion of the business is towards tire reinforcement. So out of 5 car tires in Europe, 3 of those tires consist of reinforcements from Bekaert. Then we also have steel wire solutions for accessories, as you can see in the picture there for booklets and so forth. And then we have Bryden Bekaert, which is working with steel wire ropes and also ropes, and it's roughly 11%. But this is a business segment which is gradually growing very fast, and especially also because of floating offshore wind. So Bryden Bekaert, which is where I work and where we are working with the mooring systems, we are just working with one of the fields where Bekaert is involved, but Bekaert is also active in floating offshore wind in many ways. So we have, for instance, steel wire reinforcements that Bekaert is making for the concrete reinforcements, and then we have armoring for power solutions, and then we also have the mooring solutions which are coming from Bryden Bekaert. And this is constantly expanding for us. So we are very much going wholeheartedly into floating offshore wind, and Bekaert is really seeing this as something very crucial for the future of the business also. But Bryden Bekaert ourselves, well, Bryden is an old British company and was acquired by Bekaert, but Bryden and Bekaert, we've merged these DNAs of making rope together, and we have a very strong track record when it comes to mooring. So we have many projects installed throughout the year, so roughly 172 projects completed, and there's a list there, as you can see, with some track records that we have. And we truly believe that with floating offshore wind, this track record will be longer, and we really want to be a strong partner within floating offshore wind in the coming future. Well, floating offshore wind, as you all know, it's not directly very. Floating offshore wind is not exactly the same as oil and gas mooring. Many people think it can easily replicate it, but it's not plug and play, as we say, based on those concepts. So with floating offshore wind, you have a design lifetime of 25-30 years of your mooring platform and so forth, and then you have a much more shallower installation area where you have much more dynamic sceneries where your ropes are going to be exposed to. And you also have challenges, for instance, with marine fouling and so forth. So the concepts with floating offshore wind and the requirements of floating offshore wind are slightly different from oil and gas. And therefore, you need to have a much more broader view and more insight when you work with floating offshore wind. And we truly think that synthetics is going to be a very interesting solution for the floating offshore wind business. We are active now in a few projects in floating offshore wind. So we have activities in Scotland, in France, also in Norway. We have, for instance, the Toda project together in Japan. And we also have the Mooring Sense project, which we're active in within Europe. Well, we are not a chain supplier, and I will not bash on the flaws of chain today, but I will just explain a bit about what we are offering, what we do. Well, steel spiral strand is one of the core products that we have in the company, and this is something that we have worked on for a very long time. We also have a project now, I think it's the Highwood Tampen, where we are going to supply the steel spiral strand into that project. And then we are also active in synthetic ropes, and I have my polymer background within polymers, and I really enjoy that we're working with polymers. So we have polyester nylon ropes that we are offering, and we also have high modulus synthetic ropes that we are working with also. But besides these traditional synthetic polymers that people are, which is known to people, we also have other innovation projects where we are looking at alternative polymers. We have a very good collaboration with partners. For instance, we have a collaboration now with BV Ideal, where we are looking at more tailored ropes and solutions which can be used for floating offshore wind. So we're constantly in Bryden Bekaert looking outside the box. So we have a very open view, and we try always to have a strong collaboration with partners throughout the floating offshore wind business to find the optimal solution for that. So synthetics and steel spiral strand is the core product segments for us. For us, being a big company, we are not a reptile, I would say. I think we are very entrepreneurial and very innovative in our company. We always try to find new solutions. We are very open-minded when it comes to new ideas and solutions from partners and different sites. And we spend a lot of money in research and development, and it's quite surprising to see that we're spending up to 65 million euros in research and development. And we have research facilities throughout the globe, and this is what makes us strong, that we have a strong global footprint. So we have research facilities here in the UK. We're active in China with our facilities there, in India, and also in Belgium. But in parallel to the traditional in-house research and development, we are also active in various both academic and industrial projects. For instance, Mooring Sense, where I'm leading the company's efforts, we're looking at digital twin solutions where we can detect damages early upon and then try to flag for it and see how we can take the best integrity management strategy decision for solving that damage or that issue. So we're constantly active in different projects, and we're quite open-minded on working with different projects with partners. So our team, I think some of you have probably met some of my colleagues. So Timothy Hunter, which is my manager, is quite well known in the business. Then we also have my colleague Greg Morzgai, who's the business development manager, and some of you probably have contact with Greg. But this is probably the core team which is working with our mooring solutions. But this team is constantly expanding, so we are becoming more and more people, and it clearly shows our emphasis on floating offshore wind also. So this is what I love with Bride & Bickert as a Swedish expat living here in the UK, is that you're constantly being exposed to the different dialects which exist in the country, and I love it. So you meet different people from different parts of the UK, and also people from different countries also working in the company. So in the UK is where most of our mooring expertise and manufacturing is focused now. For instance, in Doncaster is where we have our wire manufacturing, and we also have our testing facility where we are testing ropes and then different solutions. And then in Newcastle is where we have our big steel wire manufacturing plant. And in Grangemouth and in Coatbridge is where we have our activities focused towards synthetics. And that's constantly becoming larger and larger. Just quickly about this, it's quite the challenges we are facing with floating offshore wind is quite broad, and we are trying to look at the different challenges which we are facing in floating offshore wind with many different angles and perspectives. So for instance, we are looking at seabed contact. How can we improve the jacketing of the material to prevent seabed contact damage, or how can we facilitate for seabed contact storage? How can we see solutions for marine fouling mitigation? We're also looking at deployment, which is one of the important factors in my opinion, that how can we design a product where we are reducing the installation cost, and how can we improve the LCOE of the projects for our customers. So we're looking at the floating offshore wind challenges very broadly, and we are trying to tackle each of these tasks as much as we can. So the message here to everyone is that floating offshore wind is not the same as oil and gas mooring. It requires co-development, and it also requires a different view and a different perspective. And for us, we have realized this, and we always, when we work in different projects, we have industrialization in mind also, that we can scale things up. But if you have any questions or any thoughts, please feel free to contact either Greg Morzgai, or you can also contact me directly. I'm working in the R&D development team, but if it's a technical question, feel free. Thank you very much.
Thanks, Pam. Okay, right, so we will move on to our final speaker, Malcolm Bowie from SBT Energy. Last but not least, as they say.
Thanks very much, Paul. SBT Energy is a small consultancy, a small concept development company. We've been going for about 5 or 6 years, and we identify principally challenges within the offshore environment. We started off in oil and gas, but we have a team with defence background and obviously a lot of renewables as well. What we have is a range of basically buoy and subsea tank solutions. We won't obviously go into them just now, but the key one is the floating offshore wind aspect, and this is the disconnectable turret buoy itself. Our key objective is to really develop these products, these ideas, to the point where we demonstrate the feasibility of it. And we're obviously looking to reduce cost and risk and improve safety wherever possible. So what's the reason for this DTR development? And it really goes to a challenge which has been set, and a lot of us have seen this for many, many years, whereby when we are going to tow out the floating wind turbines, we've got a number of different mooring lines, we've got power cables, we have to connect them, and all of the focus has been on the individual connectors themselves rather than the overall system itself. And so when we want to potentially look at things like the tow to port for maintenance, to try and connect and then disconnect the actual turbines themselves becomes much more complicated, and it's a difficult operation. And I know I've been offshore for 5 weeks trying to connect an FPSO together, so these tasks can take an awful long time, especially the disconnect as well. So the Carbon Trust set a challenge, and we came on the back of that, and we've demonstrated that after the project's actually started itself. So the system itself addresses a particular challenge, because one of the key safety aspects is if we're going to lift a heavy structure from about 150 meters up in the air, which is what we're looking at for some of the newer generations, just a tilt of 0.1 degrees of the hull can translate to a movement of a quarter of a meter. So trying to lifting very heavy objects at such extreme heights is going to have very, very low down times. So the best option, safest option, is normally to try and tow to port. But as I mentioned earlier on, trying to disconnect, reconnect is going to be very difficult when you're doing it individually. So our system is basically trying to address this as a plug and play system. What it allows you to do is suspend all of your moorings and all your power cables off a buoy, which is then just down, can then connect into the floating hull, either at the bottom or at the side. And then each one of those mooring lines is actually picked up from part way down, because we actually hang some of the mooring lines off the buoy itself. And you can see this illustrated in the images on the right. So the top one is connected with a central turbine, and the bottom one is disconnected in the water column. And what this allows you to do is disconnect in one single operation, but leave everything ready to reconnect. So it's a very, very simple. What we do is we take some of the experience from oil and gas, and what we do is we simplify it. We apply it for offshore renewables. We've filed patents, and we're going through the due process on this. We've had a number of different due diligence and people looking through this, and it's all going the right direction. It's one of these fairly obvious structures where we actually look and say, why will it not work? Because it's actually a simplification of something that's already out there. So what it does is a number of different advantages that actually came out of the development system. But what it basically does is, as per the illustration here, the floating hull will come along, the buoy is at a depth below the hull itself, it's pulled in, connected, the connectors are already out there in terms of technology for disconnectable buoys, and then you pull in each one of the individual mooring lines, not from the seabed, but just from a very short distance. So you don't have the handling twist, you don't have the laying down the seabed. So there's a lot of different aspects in terms of how it can create a huge amount of advantages. So there's a number of different aspects where I can look at the cost and risk reduction, because we can actually disconnect very, very quickly, providing you actually have the connectors, the mooring connectors, and the technology is already out there for remote release mooring connectors. So we don't develop the connectors themselves, we develop the system itself. But what it allows you to do is reduce the amount of time to connect and disconnect. But by doing that, it reduces your weather window that you need. So it means you've got less time on standby. You've also improving the case by default. If you're improving the case for a tow to port, you can not only do the heavy lifting in port where the structure is stable, but you can also do a lot more work, and that increases the local content value, which is obviously very important for a number of these different developments. So it maximizes a lot of equipment you can do, or work you could do alongside. One of the other key aspects is that rather than leaving your power cables down on the seabed, and thus you've broken the chain, so when that turbine is away, the power can't flow, we can actually potentially connect these cables together inside the buoy itself, so that power can continue to flow even when the turbine is not on station. One of the simplest things, of course, is we can remove any electrical swivels, because what this does, the swivel is not on the buoy itself, the swivel is up at the nacelle. We're working here with a spread mooring, so This buoy will come up in one orientation. The structure will be then moored using the mooring lines at the other corners themselves. By doing less handling of these mooring systems, one of the biggest things is you're going to reduce the amount of risk of damage to the cables and moorings themselves. Ultimately, all of this comes down to reducing the LCOE. Some of the other aspects is that you can actually put your power cables in first, rather than mooring the structure first and then putting in your power cables. So it reduces your time to do that first electrons flowing through. So obviously in terms of safety, we're talking about mooring line handling. We don't need to bring the mooring lines up on deck. We don't need to thrust the vessel towards the hull to try and get the tension up. We've eliminated all of that because we're just pulling from a short distance. You just need a winch to drop down that short distance to do the pulling. For the cables, we can do a dry mate or wet mate because we can have the cables in the buoy and do a wet mate because it's deeper down, or we can pull the cables up to a higher level, but it's just a straight pull of maybe 10 meters, 5 meters. But some of the big things is that we're not laying the power cables down in the seabed. And if it comes to, say, 500, 600 meters of water, the amount of overlands and the spaghetti that you would see on the seabed, and especially buoyant cables and maybe buoyant mooring lines, it's a nightmare. You're going to have problems trying to pick these up and avoid twist and clash. So all of this reduces the risk. And one of the most important things is trying to get people out of the equation, avoid people having to handle mooring lines. So as we said, in terms of the actual design itself, we can work with whether the turbine is in one column or whether the turbine's central, whether it's a spar. We can work with any of the actual developers themselves of the hull technology. We've tried to make this as technology agnostic as possible. One of the big ones is that providing we've got the right connectors and the right control system, there is no reason why we cannot drop the mooring lines and drop the buoy. So literally you can disconnect within a matter of minutes, providing you've obviously set this up correctly. So there's all of these opportunities here. And so the big advantages with this is that it's safer, there's less handling the mooring lines, so there's less risk of damage. And ultimately, by reducing the risk, you're reducing potentially insurance premiums, and ultimately it comes down to reducing the levelized cost of energy. But as I mentioned, there's also the aspects of alongside working and increasing the local content value of it. So what we're looking to do is work with people to try and develop the actual levelized cost of energy, quantify that, see how they can work with it, and we're quite happy to work with any of the hull developers and indeed the wind farm developers themselves. So we have a brochure which talks about all the rest of our products, and we can obviously discuss that. But today it's all about the DTR, it's all about the floating wind. So we believe, and we've actually been described, that this is very simple. The DTR is simply a game changer, and we do see that it's going to be deployed. So we're quite happy to work with anyone who would be willing to work and collaborate. Thank you very much for your time.
Thank you very much, Malcolm. Okay, so we're only slightly over the time, so thanks to all the speakers for sticking to their time as much as possible. So that's great. We're now entering a Q&A session, and we've had some questions earlier, and the first one is actually to Alan. It's regarding the Carfloat product, and the question is, does it affect the reelability of the fibre rope? Assuming that's meaning when you're putting it on a reel. I'm assuming that's what's meant. Alan.
Yes.
So can you tackle that one?
Absolutely. This you can spool the rope as you normally do. The thing is that you have to be aware of is that our product is put on in form of like a tape in various layers and with various gaps. So depending on how big the gap is, you just set the spooling diameter to where the gap closes on the compression side of the spooling. So you just have to take that into account, but it has no issue with terms of sort of minimizing capacity on the reels or the spools or anything like this.
Okay.
Yeah.
Thanks for that, Alan. Hopefully that answers the question. Now we have another one. Could I ask everyone all the speakers to put their cameras on so that we can see you? We'll run a risk of using up the bandwidth here, but if everybody can come back on and just make sure that they're ready to switch their microphone in as well. Thank you. So one on the sort of export finance to Ute and Ivar. It says here, are you also looking at associated renewable infrastructure goods exported from Norway? I'm assuming that means supporting associated renewable infrastructure goods. Doesn't say exactly what type of infrastructure goods, but I think it's a more of a general question to actual items themselves.
I don't know, this is Ute. I don't know whether I understand the question 100% correctly, but any exports from Norway, whether they go directly to a project or associated infrastructure, as long as there is export of goods, and it can be services as well, we can support that. And also, if they are just parts, I mean, as sub-supplies to project, which in itself is much bigger, we can then take parts of that project and finance these.
Okay, thanks for that. I've got a question here that's I'm not quite sure who would want to have an attempt at answering this. It is related to floating wind though. So the question is there any opportunity in the sector for the provision of heavy concrete ballast up to 4.4 tons per square metre as a pumped mix in either tower bases or sea anchors? Anyone want to have a go at that?
I'll give it a go. I looked at this in the past. It depends upon whether you want to actually have it as concrete. It also depends whether you want to remove it as well. Because if you want to put in, for example, a very heavy ballast that will remain there at the time, you can certainly do things like iron ore slurry, where the iron ore will settle and the slurry itself can be pumped out, the water itself, so you have a very high density. But it also depends whether you want to actually remove it as well. We know that the drilling industry uses, I think if I remember right, barite, and it has densities up to that, but it comes down to a question of cost and also environmental aspects. So yes, there is materials out there, but they have their pros and cons.
Right, yeah, well, you actually just reminded me that Gary from Floating Energy Systems uses such that metal slurry, iron slurry in their ballasting technique, and we were talking to them about a Scottish company called Oban, who are not on this morning, but they use a gel with metal fragments actually suspended in it, which has a similar purpose. So we're just trying to work out whether the densities can match up. But I don't think it's as high as 4.4 tons. From memory, floating wind energy systems are about 3.6 tons per square metre on their slurry requirements. Okay, now
I can comment on that question as well.
Alan,
actually, yeah, there are opportunities also for making, and I'm sure my polymer composite colleague in Bryden can support me on this, that you can make what's generally referred to as HSGs, high specific gravity thermoplastic compounds that you can achieve this sort of specific gravity.
Okay.
In the range of 4 to 5.
Right. Well, I might actually come back to you, Alan, on that, given that we've got an inquiry about that coming in from one of our members. So that could be something of interest. Yeah. Now, I'm sorry, I'm conscious that we've not had much time on the Q&A. We're just about to run out of time, and it really only sort of remains to thank all our speakers today. Big thank you for the audience for coming along and spending the time with us this morning, an hour and a half, usually quite a chunk out of folks' days. So everyone, thanks for your presentations. Thanks for answering the questions. Ronnie, any last input from yourself just before we close off?
Simply to echo thanks to the speakers for keeping to time, to yourself, Paul, for organising today, and Joya for keeping us all in order. But equally to the audience, if there are any questions or queries arising out of today, or you want to speak to Paul or myself, or indeed any of the speakers, then please do get in touch with us.
Okay, thanks for that, Ronnie. And I hope to see you all again the next time we are having our joint Scotland-Norway collaboration event. probably another few good months down the line, but we will make sure that everyone knows in advance when that will be. So thanks to everyone again, and just like to say bye for now, and we'll hope to see you all again in the near future. Thanks, bye.